Welcome back to this series on amateur radio. This is the second talk in the series, and we will be looking at APRS, antenna design and satellite work. Firstly, I'm going to talk about APRS, which stands for Automatic Packet Reporting System. APRS works with packet radio and uses the feature of beaconing packets to transmit out data on the person's call sign, GPS coordinates, other telemetry data, and a message too if you would like. This has been used for tracking runners during a race, perhaps in the countryside, for tracking vehicles, whether it be a race or for search and rescue operations, and also it is used for tracking satellite spacecraft, for example the International Space Station, and also CubeSats. Let's take a look. In this demonstration, I'm going to show you how to use something called APRS, or Automatic Packet Reporting System, for amateur radio. This is a move on from the old packet stations you've seen already, and this uses packet but with a different purpose. So the system setup is essentially the same, some sort of computer, a TNC and a radio, and the way this works is, as well as transmitting the message, it transmits coordinates from a GPS device, or if you're a stationary station, you can just put your coordinates in and leave it at that. So this program here is something called YAC, which is an acronym for yet another APRS client, but there are several available, including Zaster and APRS IS32 for Windows and so on. And they all work very similarly. This one happens to be a particularly modern and good one, and it displays a lot of information. So looking at the screen here, you can see this is a map. Some of them work with a GPS display displayed over the top of essentially Google Maps, and what this is showing is stations in the local vicinity that have been heard by my radio. So we're at the centre here, and you can see it's given us a line demonstrating where conversations have come from. I believe my station's up here actually. Let's zoom in and have a look. Yes, so we're actually here, the top of this green line, and this thick green line going down to this station here is showing that I've received information from it of other stations. So as we mentioned nodes previously in the packet demonstration, this node effectively is telling me about a lot of these other stations in the area. It's heard these stations and it's forwarded the information on to me. My system's then displayed them on this map to show us where they are, and as you can see we have very good coverage all the way out towards Peterborough, further up north, and it would probably go significantly further as well if I leave it long enough and people are active in that area, but up towards Sheffield and so on, and Lincoln isn't unheard of at all. Down towards Birmingham and Coventry on the left side here, and to the south. So as you can see, we have very good coverage from this particular area. I do live in quite high up in the Nottingham area, but some of these stations as far as south as Northamptonshire as well. Now, not only can we listen to the RF signals going through the air, but this package also has the facility of plotting data that has been sent through the internet as well. So if it's a stationary setup with internet access, instead of it going through a node, as we mentioned earlier, by RF, it can actually be sent through an internet gateway type node and receive it through the internet, and therefore you can see stations all over the country. I've just noticed we've had a couple of long ones. Here we go. So there's a station up here. We'll see in a minute where that is. Okay, so it looks like they're out either on an island or in the middle of the sea. It could be that this station has put in his wrong GPS coordinates. We shall have to see. Chorley, Lancashire. So yes, it could be that he's put in the wrong coordinates. Maybe he's over here somewhere near Liverpool. As you notice, we can click on the station and we can gain information about that station, which has been transmitted from the station. Quite often you can get all sorts of information on the GPS data, the height they're at, the local location. We can also message these stations, so we can actually send him a message by picking his station out of a list and sending him a message, like a text message, similarly to what we showed with the packet demonstration. Now you'll notice on this list as well, at the beginning here, there's various options like email, and if I send out a message over the radio, if there's a local station that is connected to the internet, it can swap that message into an email to a recipient by using a certain format in my message. It will tell stations to do that. So I can actually send an email potentially anywhere around the world, provided I can send an RF message to another station that can then funnel it into the internet. Not only that, but we can send SMS messages as well in a similar manner, and we can also send WinLink messages likewise also. Now the great thing about this system is that my system doesn't have to immediately be able to reach one of these iGates, which is an internet gateway. I can actually send a message out and it will be daisy chained through several stations until it finds an internet gateway. So you don't have to be in the immediate vicinity. As long as there's other stations around that can daisy chain it to one, it will still work. So if we look at this again, we have different icons representing different stations. Quite often if it's part of a car setup, they'll have a vehicle. A lot of these squares and other icons like this mean it's a stationary station, and this particular one, as you notice here, has some sort of weather station set up, so it can give us the wind direction, wind speed, temperature, pressure, etc, etc. So very interesting, lots of great options you can do with these. And whoops, here we can again message the station, monitor it. You can actually get the system to track this station, and the whole screen will move along following that vehicle. And you can also query the station, so you can ask the station what other stations it has heard. You can send a ping to see if it receives it. You can have send a message or have an ongoing chat with them. Show line of sight, so this will give you a representation of if it can be seen on the within the horizon. Various different options. Message history. So really feature-rich options here. Here's another one that's a node slash digipeater. So this is Aprs. And let's take a look and see what it says about this one. So this station here, again we've got an idea of where it is from us, their position. It says here what frequencies they're listening to, is connected to an all-star node, which is the internet part of it. And generally APRS stations are designed to beacon. If they're a standalone station, they're designed to beacon every half an hour or so, sometimes only every hour, which is probably better because it does clog up the frequency. All these stations are using one frequency, which in Europe is 144.800, or in the UK at least. So this is all done with a single frequency, and all this information can be packed into one channel, if you like. So it's not taking up lots of bandwidth. So this is our station here. It's an iGate, and as you can see from RF alone, we are getting out to a lot of stations. So if we zoom out, whoops, again gives you an idea. Certainly the local area we're getting out very nicely, particularly to the south, but also would be to the north if anybody happened to be out. It is late in the evening at the moment, but yes, very good coverage and easy to send a message to anybody if required. Some of these stations, by the way, are just receivers, and they just receive information and pipe it into the internet. The internet website that you can check for APRS, so you can just see the internet side of things, is a site called aprs.fi. This client I have here, you can actually filter it to show you just the RF packets or just the internet or both through the options. And if you want to look at just the internet, which shows you most of the stations out there, then APRS.fi is a great way of doing it. So here we go. You'll notice if we hover over a station, again it gives us the path. So M0 SDM in Grantham, we have just reached him, and this is his information on his station. Gives him his email address and all sorts of details here, the time. We could start tracking him, etc. And this is all based on the internet, so aprs.fi. And again, if we go to information on a station, it will list all the stations it's heard, etc. directly on the radio in its local vicinity as well. So this is APRS. It can be used for tracking vehicles. So if you're on an event, like a Raynet event, and you're tracking vehicles or tracking people on a marathon, and you want to track the lead vehicle or a vehicle following up from the rear, so you know where the last runner is, this is ideal. It's all live, and it can be standalone. So if you're in the middle of nowhere, you can set up radio stations that can all reach each other, and you can monitor very closely and easily the state of a race, a walk, search and rescue, etc. Fantastic piece of technology. And all you need is a radio, a TNC, and a computer. The newer systems do have radios that have it all built in, so there's no computer, and also they do have a TNC built in. You can even get software now that is a software TNC, so you don't actually need the little black box. It can all be done through software. So these days it's even more minimal than it was. The TNCs, though, are nice because they tend to go for a very inexpensive price these days, and they're very reliable. There are many antenna designs, and these tend to be the most common. You may have seen these types from your day-to-day travels. The first aerial here is the quarter wave vertical aerial on the top left. This is popular in the hobby because it works great for UHF and VHF frequencies. A quarter wave on these bands tends to be compact enough to attach to a vehicle or house without being too offensive to the neighbours and without being too tall, hitting trees or bridges. The vertically polarised nature of the aerial means that the radio signal is radiated horizontally, which means it's going to be radiated in the best direction to be received by houses and other cars in the area. An improvement on the quarter wave is the 5/8 wave antenna. This has a very similar construction, as you can see, but with a slightly longer length and a coil placed at the bottom. This design improves the strength of the signal going out horizontally when compared with the quarter wave, and it does have a downside, unfortunately, is longer and also less compact. The next aerial you see here is the dipole. This can be situated either vertically or horizontally. Typically for UHF and VHF it is vertically polarised like the quarter wave and 5/8 wave, but can also be used effectively for much lower frequencies like the HF band, where it can be fixed horizontally due to the much greater length required for HF frequencies. The dipole is versatile and effective and can be installed across a garden, on a roof, but not really in a vehicle. Next is the long wire. This is a random length wire, typically as long as you can fit in your garden. and with extra radio equipment can be matched to multiple bands, therefore allowing one single aerial to do the work of multiple aerials without having a garden full of wires everywhere. The downside is they do perform okay, but not as well as their counterparts like the Dipole. The final aerial here that you can see is the Yagi. You may be familiar with its design if you've ever seen a television aerial on a roof. This special design is a modification of the Dipole. The radiating dipole element has what we call a reflector positioned behind it and director elements placed ahead of it. The size and spacing of these elements gives the aerial the ability to direct the radio signal in a single direction. This means it behaves a bit like a torch and shines the signal only in the required direction and does not waste effort or energy in other non-desired directions. This gives the effect of a much better range in both transmitting ability but also receiving ability. The downside is that if you're trying to listen to the whole area that you're in, you'll not be able to hear very well in any direction other than that at which the aerial is pointing. There are many other designs of aerials, and if you're interested in learning more about them, I'd highly recommend joining your local radio club. This is the end of talk number 2. I hope you found it informative and interesting, and I look forward to seeing you in talk number 3.